Our next speaker is Vidya Gopalakrishnan. And Vidya completed her master's in information security from Carnegie Mellon University a few years ago. And she's also worked at Ford, but now at Palo Alto Networks as a security operations engineer. And but in this time, she's already presented to thousands of people on Security Operations Center best practices, and will share her knowledge on hunting in the cloud. So I'm going to hand it over to you, Vidya.
Thanks, Frank. Thank you so much for the opportunity. And it's a great honor to be talking alongside some of the most accomplished individuals in the cloud security space. So today I will actually be taking you through how you can mind map your way into the cloud and what is the thought framework you can use to hunt through AWS and GCP. So in this talk, we'll get into the nitty-gritty details and sort of get into the weeds of what an actual attack may look like in the cloud and how that would actually translate to data that a defender can then use to be able to do threat hunting. So if at any point it gets a little overwhelming, do not worry, we're in this together. So let me see if I am able to transition through this. So before we actually get into the presentation itself, just a little bit about myself. I'm Vidya Gopalakrishnan, and I work for Palo Alto Networks as a security engineer with their Blue team. I lead the threat hunting program within our SOC, and I've been in the cybersecurity space for about 5 years. All of them have been in Blue team roles. So prior to Palo Alto Networks, I used to also work for a Blue team with a major auto manufacturer. When I don't do security stuff, I sing, I paint, I do a lot of old school Renaissance stuff. So if you're interested, do connect with me. And these are my social media handles if you want to connect with me post the presentation and want to learn a little bit more. So without any further ado, let me actually start by talking about what a dual threat detection process really means. So when we talk about threat detection, we're talking about two different actions. One is hunting and the other is alerting. So when we talk about hunting, hunting is, by virtue of it being called as a hunt, much like, real hunting, it's kind of like you chasing down a certain hypothesis and trying to find a needle within the haystack. So this means, you might actually end up looking at thousands of logs, and you might end up looking at events that might probably turn out to be pretty low fidelity. So when I say quote unquote low fidelity, it basically means that when I hunt, I do not really expect that to be a true positive event or an actual threat. Alerting, on the other hand, is one where I do expect, high fidelity events, or events that would necessarily wake me up at 3 a.m. in the morning. So in this dual model of threat detection, what we're essentially trying to do is we try to hunt as much as possible so as to be able to uncover as many high fidelity use cases that we can then configure for us to be able to get alerted when something really bad happens within our cloud infrastructure. So speaking of cloud infrastructures and the attacks with respect to the cloud, the MITRE organization has actually put up a very comprehensive framework of sorts that enlists the different attacker tactics, techniques, and procedures. So upon first glance, again, this might seem a little overwhelming. It enlists a lot of different tactics. So how am I going to get my head around this as a defender? But if you actually look very closely into it, and when you look at the columns on the top of that particular framework, you can see that it is designed keeping very much in mind the progression path that an attacker would take. For example, an attacker would probably get into your cloud environment by some kind of initial access method, and then he would try to establish his foothold via persistence, doing some exploitation, evading any defenses, and then trying to sort of spread the attack by moving laterally through the cloud network or cloud VPCs, etc. And then finally taking out all the cloud or all the confidential data from your cloud infrastructure, or using those very resources within the cloud itself to be able to do something like Bitcoin mining. So given that this is kind of like the attacker progression, as defenders, how are we going to hunt? Where do we start? So when we look at it as defenders, defending the cloud infrastructure, and when we want to threat hunt for anything that might have occurred in our cloud environment, we're going to start off with the assumption that something really bad actually already happened. And that is the reason why it's recommended that we start our threat hunt from the right to the left. So as you can see here, the farther right of the entire progression looks for things like Bitcoin mining or abuse of resources to do some kind of attacker activity. And then, when you go a little bit further down the left, it talks about exfiltration and things of that nature. So as you can see, the severity is much higher on the right side. And therefore, when the severity is high, it's better to concentrate or focus our hunts more on that side and then progress slowly from right to the left. And then when we speak about fidelity, we also expect that the fidelity will be high on the farther right rather than on the farther left. Therefore, the fidelity will also increase from left to right. From right to left, and therefore we need to make sure that we focus our hunts on the high fidelity use cases first, and then go down the progression path to be able to do better hunts and effective hunts. So now that we've talked a little bit about threat hunting itself in general, let's also talk a little bit about the cloud and how for a defender it will actually look like. Because we can talk about frameworks, we can talk about all of these different threat models and everything all day long, but then for a defender, we will actually want to speak in terms of specifics in terms of log sets or the actual logs that we'll be using to defend against any attacks on the cloud environment. So there are two basic log mechanisms that AWS and GCP provides. So AWS already provides a mechanism called Cloudtrail, and GCP provides something called GCP logging or GCP operation suite. It was formerly known as Stackdriver. So for the rest of the presentation, we will just refer to that as Stackdriver. So Cloudtrail and Stackdriver are two logging mechanisms that will help you track attacker activity via something called API calls. So we need to be cognizant of the fact that these API calls are really powerful because both an attacker and a defender can use them for different purposes. An attacker can use these very API calls to access and exploit your cloud resources. And those very same API calls can also be tracked on the defender side to be able to track the attacker activity. And this is something that I'll be showing you as an example later in the presentation. So that's, the exciting part is yet to come. And on the GCP side, just like Cloudtrail, there's a Stackdriver. Cloudtrail has three kinds of events. There is management events, data events, and insights events. For the purposes of this presentation, we're just going to confine ourselves to hunting only on management events on Cloudtrail. And similarly on GCP, we're only going to be trying and focusing our attention on GCP security audit logs. So given that we have given you a rough idea of what Cloudtrail and Stackdriver is, let me show you a sample AWS Cloudtrail log and a sample GCP log. So as you can see, this is basically a giant JSON blob that has a bunch of very important information. It has the principal email that is associated with that particular cloud resource. It also contains something called the event name. So the event name is very important, and this might come up a lot when we are actually getting to the stage where we are going to construct our mind map. So just keep that in mind. This event name is going to be corresponding to the actual API call that is being made against the AWS infrastructure. We are also going to be seeing a couple of other fields like source IPs from where the API calls generated. So this could also be a really good field that that a defender could use to understand if any of these API calls are being originated from known bad IPs, for example. There's also things like user agent. There's also a field that tells you what exactly is the resource that is being called against, meaning whenever there are API calls against AWS or GCP, you're basically doing those actions against a certain resource or a certain service within GCP or the AWS. So AWS has several services like S3, EC2, AWS Secrets Manager, etc., or Lambda, etc. And GCP also similarly has deployment manager. It has compute instances. It has GCS buckets and things of that nature. So all of these are the different services, and those services are also going to be showing up on your AWS Cloudtrail and on your GCP Stackdriver log. So this is a sample AWS Cloudtrail log, and this is another sample GCP logging event. Both of these are extremely similar, except for the fact that instead of event name, there is something called method name in GCP logging. So just keep that in mind. So going forward, let's actually get to the meat of the presentation, right? We've talked about Stackdriver, we've talked about the different attack, the MITRE attack tactics and techniques and everything. But how do we tie this all up together? This is where a mind tool, so this is basically a psychology tool called mind mapping. So mind mapping is something that a lot of executives and a lot of practitioners use in order to organize their thought process to solve a certain problem. So in this case, we're actually trying to solve the problem of doing hunting on AWS and GCP. Mind mapping, AWS API calls to MITRE attack tactics itself is not something novel, or it's not something that is happening newly. It was already done, by a couple of practitioners in the industry, including a firm called expel.io, who published a framework that ties in together the MITRE attack tactics to the different AWS API calls, which can then be used as an aid for investigations, etc. We are not going to use the same mind map. We are going to augment this mind map with a couple of elements, which I'll be talking to you in a bit. There are also several resources out there that attempt to sort of mind map AWS security controls itself that are natively present within the environment to MITRE attacks and things of that nature. So mind mapping is not something that is new. In this presentation, what I'm going to tell you, or what I'm going to talk to you or walk you through, is basically a mind map that will let you put out a schema of sorts, basically for every MITRE attack tactic. So the mind map will basically consist of a MITRE tactic. It will consist of the AWS or GCP service that it's actually trying to map it against. And we're also going to be seeing what are the API calls that are pertinent to that particular tactic and to those particular services. We are also additionally going to see how to draw out hypotheses within the mind map, and also be able to assign a fidelity ranking to it to understand which of the techniques are, which of the tactics are suitable for hunts and which of the tactics are suitable for alerts. This might be a little too abstract at this point because it's all pretty textual and we don't really have an actual mind map to look at. So let's actually get started with constructing one, right? So for example, let's take credential access. That's our example tactic, right? If we have to construct the mind map based on the schema that I just told you, we start off with what are the different event names? What are the different AWS API calls that would be pertinent to credential access? So some of them are get secret value, list secrets, update secret. So AWS API, actually, the documentation is pretty exhaustive. Like all of these different API calls have explanations of what they actually do and what they actually are. And so if you go into looking at looking at the descriptions for each of these, you would get to understand that each one of this basically could mean that a potential attacker is trying to gain credentials from a service like AWS Secrets Manager or from your EC2 instances. And that is the reason why we have also listed the services as EC2 and AWS Secrets Manager. After we have listed what are the event names we look at and what are the services we look at, although this would give us a good primer and good starting point to be able to do some hunting, we wouldn't necessarily be able to go after a certain hypothesis or a structured way of looking at it. So in order to make it more structured, we are drawing out two particular hypotheses under this tactic. The first one being looking for rare occurrences of any credential access attempts. That is, look for AWS API calls like get secret value, list secrets, update secret, etc. But look for rare occurrences of those, because I don't want to be lost into the noise of some kind of administrative benign activity that is going on within my environment. So for that purpose, I'm specifically looking only for rare occurrences. And I've just given like a sample pseudocode of how you can do that. You can classify rare based on its ID, or based on the source IP that it's coming from, based on the timeline. There are several other factors that you can use with the pseudocode to look for this hypothesis. So when you look for rare occurrences, it is expected that the fidelity would be a little high. It wouldn't be as low as you getting sort of lost in the noise of administrative activity in the cloud as a defender. And the second hypothesis is you looking at administrator password retrieval from Windows EC2 instances. So there is a particular API call called get password data. So if you actually go into the AWS API documentation, you'll understand what this exact API call does. This basically tries to retrieve the Windows administrator password, or the administrator password for any EC2 instance, Amazon EC2 instance that is running a Windows AMI. And that doesn't really happen as much, but in case, again, if there are administrators or DevOps people within your environment that are running scripts and they want to regularly retrieve passwords, this might prove to be a little noisy, and that is the reason why I've made this expected fidelity of it as medium. So as a result of all of this hypothesis, the resulting fidelity of the technique itself, and you can draw multiple other hypotheses within the same tree, right? But based on all of that, we could come to a conclusion that this credential access as a technique itself is a pretty medium fidelity technique. That is, it could be either alerted on or it could be hunted for, depending on which hypothesis you actually choose to chase down. So that is kind of like the idea behind how we are going to construct the mind map. So just imagine that I've done this for all of the other MITRE ATT&CK tactics that I explained before. If I put all of that into a giant mind map, this is probably what it's going to look like. You don't have to worry if you cannot read out each one of this. I'm definitely not going to go into the details of each one of these because it might be pretty overwhelming. But the idea is really that we apply the concept, we apply how to construct a mind map for doing hunting across all of these different tactics on AWS, and also similarly on GCP. And we just try to understand which of the tactics are more or are better for alerts, and which of them are better for hunts. So that's pretty much what we are going to do. And once we, I think, get into the examples and get into the use cases, it might get a little more interesting, and it might get a little bit more exciting to understand how we can put this to use. So without further ado, let's actually go ahead and do that. So some of the example use cases. So there are two specific attack scenarios that I'm actually going to walk you through. So in this case, we're basically going to don two different hats, right? We're first going to see how the attacker does it. Assume that I'm the attacker and I'm also the defender. First, I'll be going through the attack cycle, how exactly the attack is happening. So the nitty-gritty details of what exactly are the commands that are being run by the attacker, etc. And then after we complete the attack, we'll then be seeing on the defender side how it's going to appear on your Cloudtrail logs or on your Stackdriver logs. So the first use case that we're going to be seeing is how an attacker would abuse the AWS lambda function and also improperly configured or overly permissive roles within AWS to gain full admin access. And you don't have to worry if you do not know the basics of what a lambda function is or anything of that nature. Basically, what a lambda function is it's a serverless service that AWS offers for you to be able to write in code anything that you can and that you should be able to do with any AWS services. So instead of you having to manually, for example, create an EC2 instance, you can just write AWS lambda code to do that. That way, you're basically cutting down on the resources that you're using, and you're all doing it. I mean, you're basically doing it serverless. That's essentially what lambda does. It's just a way of writing your own custom functions to do custom things with your AWS resources. So how does the attack actually happen? We are going to start off with a very insecurely configured environment first. We are going to assume that there are some overly permissive roles within that environment. And in that environment, as an attacker, I am going to abuse three specific roles. One is, or three specific permissions. One is the IAM pass role permission, the lambda create function, and the lambda invoke function. So if these three are present, or if there is a role that has these three permissions enabled, the attacker may actually be able to privilege escalate and get God level access on your account. And let's see how that actually happens. For this to happen, we're actually going to use an open source tool called CloudGoat. It's actually an open source tool that was published by Rhino Security Labs, I think late last year. I will publish this resource on the Slack channel for you guys to be able to go and take a look. So using Cloud Goat, we're basically going to spin up a vulnerable environment with overly permissive roles. We're going to also have a user called vulnerable user, whose access token we are already going to assume that we've got our hands on, meaning that the vulnerable user's access key token somehow got exposed and the attacker was able to get a hold of it, and by way of that, he's able to abuse and create his own profile within that AWS account and abuse it end to end. So that's really what's going to happen now. So let me actually get you into the specifics of how the attack is going to happen. So using Cloud Goat, the vulnerable instance has been, the vulnerable AWS environment has been spun up. Overly permissive roles have been created. All of that has been already done using a Terraform script within Cloud Goat. So all that is done. But now I'm the attacker, and let's call me Chris, for example, right? Chris, what he's doing is he's going to configure his profile into the AWS account using the access key ID and the secret key that he's being given when the vulnerable environment is spun up. And then once I create my profile, I want to understand as an attacker, okay, what are my current permissions looking like? What permissions do I have currently? And how can I use my current permissions to build out a path to be able to get God level access? So for that to happen, the second and the third command are basically looking for the attached policies and the permissions. So when you look at the bottom here, it basically says that Chris, our attacker, basically has all allow access to assume a role. He can assume anybody else in any other roles, policies to himself. He can also list permissions, and he can also get permissions. So these are the only permissions that he has currently. The goal of the scenario is basically to make sure that Chris has administrator access where resource equal to star and action equal to star, meaning like he can do anything and everything as and when he pleases in your AWS account. That's basically God level access, and that's exactly what he's aiming for as an attacker. So how is he going to go ahead and do that? For that, he will first enumerate all of the roles that are already present. So for that, he's going to list all of the roles in that particular project. So when you list all of the roles, the attacker particularly tries and looks at two very interesting roles. One is called the CG debug role, and the other is called the CG lambda manager role. These look like custom roles to him. These look like something that a user may have custom created with custom permissions set for it. So he's curious as to what these two roles actually are. So he goes ahead and actually looks at what are the permissions that are associated with each one of these two roles. That is the CG debug role and the CG lambda manager role. When he does that, he, to his very good surprise, discovers that CG debug role has administrator access. Remember, he's not assigned this role. It is just a role that is already on this project. He wants to somehow abuse this role and get God level access from this role. He also tries to do the same kind of enumeration for the lambda manager role. And when he gets to do the permissions for it, he sees that the lambda manager role has all access to lambda and has a pass role permission, meaning that if I run a lambda function using the lambda manager role, that lambda function could potentially pass a role from any other existing role to Chris, the attacker. So that's essentially what that's essentially what this blog means. So now that he has the information about what CG debug has, what lambda manager has, what his current permissions are, he's going to use all of that to privilege escalate. And how is he going to do that? The first step he's going to take is he's going to assume the lambda manager role. So remember, in our first slide, we already saw that Chris inherently has the permission to assume any role. So he's assuming the lambda manager role. And once he assumes that lambda manager role, he's going to be able to get its credentials, he's going to be able to get its access key, etc. And with that very role, he's going to create a lambda function that will then say at the bottom, hey, lambda function, I am now lambda manager because I just assumed the lambda manager role. So why don't you run a function for me and give me complete administrator access? And this will actually go ahead and get invoked and get executed. And guess what? Our attacker Chris just got full admin access on our cloud environment. This so the last blob over here basically says that the Chris username doesn't just have the CG Chris policy attached to it, but he also has full administrator access, meaning he could do anything and everything that he wants to do with the account that he now has access to. This is a pretty nightmare scenario, right? And if this is the case, and as an attacker, this is the best case scenario, but for a defender, this is definitely a nightmare. So in order for us to be able to hunt through something like this, what do? This is where we go back to our mind map and we say, okay, let me, as part of today's or this week's hunting exercise, try and hunt for privilege escalation. And when I hunt for privilege escalation, I basically go ahead and look for what the event names that are listed on my mind map are, what are the two hypotheses or two or whatever number of hypotheses I'm actually trying to chase down, and I'm going to be hunting for all of those different hypotheses. So in this case, I'm basically looking for any rare creations of lambda functions, and I'm also looking for any role changes that happened. That is, any user policy that got attached or any role that got attached and things of that nature on my Cloudtrail. So with this idea, we now go into, as a defender, go into the AWS management console. We go into Cloudtrail and we go into event history. So you may or may not use event history depending on whether you already have a Cloudtrail created, but event history is something that will automatically log 90 days worth of data for every project. So in this case, we see that there are a few functions that actually stand out. Or a few API calls that actually stand out. For example, the attach user policy is happening with a username called admin function, and it's happening pretty rarely. And we are also seeing that the attach role policy from the vulnerable user is happening. So this might have probably meant that someone has spun up some kind of extra role for themselves. So we go ahead and investigate the very first Cloudtrail log over here, which is the attach user policy event. And when we go and look at it further and look through the entire blob, it says that someone has assumed a role, and that role was assumed using a lambda function called admin function. This lambda function did the graces to give over the roles of CG debug to this guy called Chris. And the role that was actually passed was administrator access, meaning the role with administrator access was just passed to this guy on this time, and this is how you see it on the Cloudtrail. So there it is. You basically detected privilege escalation, and from here onwards, your incident response plan can kick off, and you could start to destroy the resources and take up the necessary mitigation steps. When we talk about it from a responsive perspective, we talk about mitigations, but all of our previous talks in this forum talked about how we could prevent this very thing from happening by using AWS config and using the pre-built security controls that are already present within AWS to make sure that we don't have overly permissive roles like this. So that's your first scenario, and I hope that made sense as to how an attack happened, a defense happened, and then how we actually were able to threat hunt using our mind map. So it's a very similar scenario for GCP as well. We're going to do something extremely congruent to what we did in AWS, except for the fact that instead of having a custom role, we'll have something called the legacy role in GCP. So in GCP or in the Google Cloud Platform, there are something called legacy roles, which tend to be sometimes overly permissive. And when you take up those roles, you tend to basically get permissions to do a whole bunch of things, and which might not even be necessary for the kind of project that you're working on. So in this particular scenario, we're going to assume some of the very same things that we assumed in AWS. We are just going to assume that there's a user whose secret access token somehow got exposed to the attacker, and using that secret access token, he's going to test the permissions of this particular vulnerable user. And once he understands that there are vulnerable permissions attached to this user, he's going to go ahead and create Bitcoin mining deployments within the GCP project. So let's just quickly run through this because it's a very simple scenario. So in this case, what we're actually going to do is we're going to have a access token that was stolen. And the project for which it was stolen is called the Huntress Project 101. And then he's the person who's trying to deploy a Bitcoin mining infrastructure is going to try and open up deployments, create config.yaml. So deployment manager is kind of like an infrastructure as a code kind of a service in GCP, wherein you can basically spin out services, spin out instances and whatnot without having to use individual API calls. You could just use the deployment manager, give a certain configuration saying, hey, these are the number of instances, these are the kinds of instances I want to be creating, and the deployment manager will take care of that for you. So the YAML file basically looks like this. So as you can see, BTC craze 1, BTC craze 2, BTC craze 3. So it's basically like Bitcoin crazy. It's basically like a Bitcoin crazy infrastructure. So there are hundreds of these instances, or tens of hundreds of these instances that might be created as part of this configuration. And once this, the access token is gotten, you basically have to pass it through an exploit script. So just like Cloud Goat, there's also an equivalent GCP exploit script that Rhino Security Labs published. And using that very same thing, you'd be able to pass the access token and be able to create deployments to your liking as much as you want. So once the access token is gotten, they're basically going to go ahead and deploy the script, the exploit script, and that will go ahead and insert the deployment and the tens of hundreds or how many ever instances you specified in your YAML file. So that is just like how we hunted in AWS. We're going to do something very similar in GCP. We're going to look for high number of instance creations as one hypothesis. We're also looking for rare creations of deployment managers. That's also another hypothesis. So while hunting down these two, we see on the GCP logging console much similar to the Cloudtrail event history that we saw. In GCP, there's something called the GCP logging console, where we can actually see the deployment manager insert function that happened, and also a whole bunch of compute instances that got created within just like a few seconds. So that might potentially mean that someone is trying to spin out a whole deployment for doing whatever they want to do. And we can also go and look at the deployment manager itself to see how the infrastructure got created, and also look at the VM instances that got created. In this case, I've just deployed like 5 instances, but in a real Bitcoin scenario, Bitcoin mining scenario, there could probably be hundreds of this. Who knows? So yeah, that's basically your second scenario, where the attacker was able to get the access token, was able to just make use of a user's legacy role as editor to deploy his own infrastructure and create as many number of instances as he wants to. And that was hunted down through our GCP Stackdriver. So that's pretty much all I actually had for this talk. I hope you all enjoyed it. This is just like a start to think about how you can do hunting if you were to actually go down the path of investigating any incidents on GCP or on AWS. So I'll also make sure to publish any resources that I have on the Slack channel, just so that you guys have a reference to that. Over to you, Frank.
Oh, hey, Vidya, that was amazing. I love that talk. That was just jam-packed with so much awesome practical information. A couple questions. In the mind map itself, you had the fidelity of the hypothesis, and it was high, medium, and so on. You had a question come in: is that, have you seen any way? Is it worthwhile to think about doing that quantitatively versus qualitatively?
That's actually a great question. So in order for you to be able to do it quantitatively, you may have to be doing it repetitively and gaining data metrics out of it. So only when you for example, like repeat a hunting exercise over time, would you be able to understand how many times it's actually giving you true positives and how many times it's giving you false positives? So that's going to have to be a much more elaborate exercise if you want to go down the quantitative route. And of course, that's the much more informed route. It's a very data-centric route. But if you're going to go via the qualitative route, it's at least going to give you a start saying, hey, I at least have some kind of detections in place. I don't really know if this might give me a threat, but I'm still going to place it as a detection just so that I have visibility to it. So there's a pro and a con attached to both, and it really depends on what your resources are, how much time you can spend on it, how much time you can actually spend on building a detection and things of that nature. So
great. In the Mindmap overall, you had different colors for some of the different parts. Was there any significance to the colors?
Not really. It was just, more like, okay, if it's cool, then it's blue, and if it's blue, then it's probably just going to be a hunt and not something that will wake me up at 3 a.m. If it's red, then it's more like red alerting and all the sirens going off. So that's kind of like what was going on in my mind when I was color coding it. But it really doesn't really, it doesn't really have any significance. You can color code it as just like how you want to.
Great. Yeah, and you did an amazing job of showing the foundational info in those Cloudtrail logs and what to look for and how it's associated with the roles and privilege escalation. From a tooling perspective, how do you suggest that people start to think about it from a free tooling perspective in comparison to a commercial tooling perspective to start to automate some of these things?
Great question. So some of the organizations, they have subscriptions to like AWS Guard Duty and services of that nature. So these services, like they already go ahead and detect some of these kind of privilege escalation techniques. I think I've not used Guard Duty, so I don't really know if I can speak to it. But it is important that you sort of like weigh the cost factors associated with everything. And also the resourcing that you have available to be able to build out these kind of detections, either using your own custom logs or by ingesting Cloudtrail or by using something like Guard Duty, or you can even do a combination of both, just so that you have as much visibility as you can. So it really depends on two factors: resourcing and cost at the end of the day, really.
Yeah, great, makes sense. Hey, well, I really appreciate your talk. That was awesome. Everybody, let's give Vidya a virtual round of applause. Thank you so much for being here, sharing your knowledge. And we're going to go ahead and move on to the next speaker. Thanks again.
Thank you, guys. Stay safe. Bye.